Cool, let's take a look at another problem. I'm just going to hide this one real quick. Okay, so this time the function is f of x is equal to negative 4 over x. I'm going to start with negative 4. I'm going to substitute negative 4 in for x. So f of negative 4 is equal to negative 4 over our x value, which is negative 4. So negative 4 over negative 4 will give a value of 1. And then I'm just going to keep moving through. I'm going to change colors though. Alright, so now next it's f of negative 2. F of negative 2 is equal to negative 4 over negative 2, which is equal to positive 2. So f of negative 1 is next. F of negative 1 is equal to, well, negative 4 over negative 1, which gives value of 4. And then f of negative half, or 1/2 here, and I'm going to fix that parenthesis, it's equal to negative 4 over negative 1/2, which will really give us, negative 4 over 1 times negative, in fact I'm going to just put that negative symbol off to the side, negative 2 over 1, because I flipped the reciprocal, and I'm going to multiply negative 4 times negative 2, which will give me a value of positive 8. I'm going to fix that 8. There we go. So 0 is undefined. We are not going to use it. But just to prove that it's undefined, I'll go ahead and put it in here. So f of 0, it's equal to negative 4 over 0, and any number divided by 0, it's undefined. So undefined. All right, let's move on. All right, so now we have f of 1/2, and I'm going to wrap that in parentheses there, is equal to negative 4 over 1/2, positive 1/2. And when I flip the reciprocal of 1/2, well, I'll end up with negative 4 over 1 times 2 over 1, which will give me a value of negative 8. And I think you're starting to see the pattern here now. So now we have f of 1 is equal to negative 4 over 1, and I'm just going to write the other few out now. F of 2 is equal to negative 4 over 2, and then f, I'm going to fix that f real quick. F of 4 is equal to negative 4 over 4, and let's figure out what these are equal to. Alright, so negative 4 over 1 is negative 4, negative 4 over 2 is negative 2, and negative 4 over negative 4 is negative 1. Cool. So now I'm just going to plug these values into the table. Alright, so when x is negative 4, y is 1. When x is negative 2, y is positive 2. When x is negative 1, y is positive 4. In fact, I'm going to fix that 4 real quick. And when x is negative 1/2, y is 8. We don't use 0. It creates a value that's undefined. When x is 1/2, y is negative 8. When x is 1, y is negative 4. When x is 2, y is negative 2. When x is 4, y is negative 1. Well, let's go ahead and plot this information. Okay, so when x is negative 4, y is 1. Starting at the origin, I'm going to go negative 1, negative 2, 3, and 4, and up 1. So y is here, or my point is here. When x is negative 2, y is 2. So negative 2, up 2. When x is negative 1, y is 4. So negative 1, 1, 2, 3, and 4. And when x is negative 1/2, y is 8. So negative half, up 4, 5, 6, 7, and 8. And then on the end, I'm going to fix that last one there. And then on the other side, so when x is 1/2, y is negative 8, so half, and then 1, 2, 3, or negative 1, negative 2, 3, 4, 5, 6, 7, and 8. So right here, When x is 1, y is negative 4. So 1, then negative 1, 2, 3, and 4. When x is 2, y is negative 2. So out 2, down to negative 2. And when x is 4, y is negative 1. So out 2, 3, and 4, down 1. Okay, so let's draw lines through these points. As the line approaches the y-axis, it comes close, but it never touches it. And it would go on, and moving in the opposite direction as it approaches the x-axis, it gets closer to it, but it's never going to touch, and it's going to go on this direction forever. So I'm going to actually just fix that arrow one last time here. And now moving on to this other set of points. All right, so as the line approaches the x-axis, it's going to come close, but it's never going to touch. And I'm just going to draw my arrow now. So it's going to come close, it will never touch, and move in the opposite direction. It's going to approach the y-axis. It's going to come close, but never touch. Okay, now let's just see what this visual is telling us here. So I'm going to actually consider it when comparing it to as one variable increases, the other decreases. Let's see if that's true. So as x decreases, as I move along to the left, what's happening to the value of y? As x decreases, y is actually decreasing. So that's not holding true. Let's go to the opposite direction. As x increases, as it moves to the right, what's happening to y? Our y value is increasing. So that's not holding true. It doesn't look like as one variable increases, the other decreases. Let's go to this opposite side. So on the opposite side, we can see that as x decreases, as we move to the left, y is decreasing, and over here, as x is increasing, y is increasing, the value for y is increasing. So what the heck is going on here? Okay, so what we really have to do is go back to what inverse variation is and think about that definition. It's a relationship where two variables are proportional so that the product of the two variables are constant, that they give us a constant value. So when I multiply x and y together, that's why I like this equation so much, because I can just think about it as when I multiply my variables together, I should get the same value for k, or the same constant value. So let's think about this, and I'm going to just change pen colors here. Okay, so now what we're going to do is just think about it as, well, what's the product of x and y? Well, negative 4 times 1 will give me a value of negative 4. So I have negative 4 here, and I'm only going to work through a few of these. Okay, so what about negative 1 and 4? So that will also give me a product of negative 4. And let's go ahead and look at 1/2 and negative 8. So 1/2 times negative 8 will also give me a product of negative 4. So what we're seeing here is that we're getting a constant product, and we'll just do one more. 2 times negative 2, let's do that. So 2 times negative 2 also gives me a product of negative 4 here, and I'm going to fix that 4. So negative 4, so my value for k is constant. K is always going to be negative 4. Therefore, we have an inverse variation. I'm going to get rid of just some information. I just want to look at the two graphs together. I'm just going to slide this information over. Let's go ahead and just slide that on over there. Get over there. Perfect. All right, so that should work. So now we can compare the two graphs when k, our constant, is positive compared to when k, our constant, is negative. And these are the general curves that you're going to see with these functions here. All right, so I'm just going to change pen colors. So again, just to refresh, to make sure that you have inverse variation, make sure that the products of your two variables are always constant, or that the product is always the same. We're not going to substitute 0 in for x. In k, it's not equal to 0. Cool, I'll see you in another video.